Okay, this chapter is starting with triangles. And we have several chapters that deal with triangles, and they're actually combined two at a time. So this and trigonometry will be together. So this is where they start off easy. Okay, and there's your little math joke from a long time ago. We're going to be classifying the angles, measuring, and more. All right, so when you name a triangle, you name it with a triangle symbol, okay? That's easy. And you can put the points, the vertices, in any order that you want. ABC, BCA, doesn't matter the order. Okay, when you classify it, you're going to be looking at two different ways of classifying it. Does it have any matching parts? Usually we're talking about sides, but it doesn't have to be just the sides. Are there any matching parts? And what are the size of the angles? Okay, two different ways to classify it. So it has two names every time you classify it. So the first is looking at their sides and equilateral. What does that make you think of? Equal, of course, means equal, and lateral means side, so three equal sides. Equilateral. And there's an equilateral triangle. And if you ever encounter one, you'll get to see that the angles actually all match. Three equal angles will go at the same time. And think about this, a triangle always adds up to be 180. So if you cut it into three equal pieces, divide it into three equal pieces, each one is going to end up being 60 degrees. So anytime you've got an equilateral, it's actually going to be 60, 60, 60 for all three corners. Next, we have isosceles. So, isosceles, think about SOS, two S's right there in the front, but it's got three total, but two sides congruent. Now, the technical definition is at least two, so that could lead you. If it had more than two, it'd be the three, so that would be equilateral, but for some reason they're calling it at least two, but I always think of it as just two. So two equal sides here and here. It will also have equal angles to go with it. And then finally, scalene has none of the sides congruent. So boom, 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 three different lengths on each side, okay? Now, you can do this with just angles. They don't have to tell you anything about the sides. They could have it with just the angles, and that would mean, hey, I got 60, 60, 60, all three in this one, or I've got two matching angles here, makes it isosceles, all right, and the one at the top could be whatever, and then the one at the bottom, no matching angles, no matching sides. So the sides and the angles go hand in hand. If you got sides matching, you got angles matching the same number. All right. The second type is a classifying according to the size of the angles. Now, equiangular, think about it, there's your equal again, is also equilateral. So whenever you got an equilateral, it's equiangular, equiangular, equilateral. It's the same exact thing, but this is referring to the angles matching. The second one, acute. Now, all of these are acute angles. They're less than 90 degrees, but what's more important, being less than 90 or being equal? Being equal. So that one's more equiangular. You call that'd be more important. But an acute angle would be one that would be all less than 90 degrees. Now, it also has nothing matching, so what is that also called? Okay, scalene, good. All right, remember acute, okay. So, and then the right triangle has one right angle, only one. Now, why can't it have two right angles? Got a right angle here and a right angle here, I can't make a triangle, can I? All right, so plus it doesn't total up right. You have to have three angles, and so only one of them could be a right angle. And the same thing with obtuse. If you've got, you can only have one obtuse angle, the real wide one, the other two have to be acute, or it won't add up to 180 like it's supposed to. So this is the size of the angles, okay, and equilateral, angular too. And the other one's dealing with matching parts of the angle of the triangle. All right, so let's see, little quiz time here. Not nothing you got to fill in, but just asking questions. All right, it's going to highlight certain ones. ACD, triangle ACD, right here in orange. What type is it? Can you guess? What type is that orange? Do any of the sides match? All right, then what about the size of the angles? Size of the angles, see this one right here? What does that look like right there? Obtuse and scalene. None of the sides match, and it is obtuse, that real big, wide open angle right there. Next, let's look at ABC right here. We got the marks. Look at the marks. Okay, so if it's one, then it's automatically the other one too. Equilateral, equal angular. They go hand in hand every time. All right, ECD. Can you find it? ECD. Yeah, right there. All right, what do you see right off the bat, hopefully? A right angle, yeah. And then what about sides matching? Okay, so scalene, none of the sides match, and the hypotenuse definitely would not match. Remember that? It's got to have a different, it's going to be bigger. All right, next and final one, ACE. ACE, another right scale. How'd you do? All right. What about these? Classified according to their sides, just the side method. That'd be isosceles, scalene, equilateral. So this one, anything match? So that is scalene. And then here, even though it is a right triangle, what's the other type? It's got two matching angles, isosceles. Okay. And then the ACT comes along and throws a whole big monkey wrench into it. You got these points, and they want to know what's the classification of that triangle. So if you graphed them, you can see it, and you're like, well, maybe it's a right triangle, maybe it's not, maybe it's got matching sides, maybe it doesn't, I don't know. But what can we do that we've done in the past? If we got a drawing we can look at, we can count. So across the top, that's 10. Now how do you count the other? Remember, rise and run. Go down, straight down from A, straight across to C. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8. Alright, so Pythagorean theorem. Oh my gosh, we gotta do it again. 6 squared plus 8 squared will give you the hypotenuse squared. Remember? This is the hypotenuse, right angle right here. Alright, so slanted parts of hypotenuse. Add it up, work it out, it actually works out to 10. So, even though you couldn't have guessed it, if that's 10, we know it's at least isosceles. And then look at this last one, you can count up real quick, boom, boom. And I think that's like 2, I didn't line it up too good. 2 and 6 going across, 2 squared plus 6 squared. Going to be 4 and 36, that's going to make 40, that's not going to be 10. So we only got 2 sides matching, isosceles. Okay, pretty good. Alright. Alright. Interiors of a triangle, the inside angles. You got 1, 2, 3 angles. They might be the same, might be different. But all we know is they have to add up to be 180. Watch here, straight line 180. Every time you take the corners and line them up on that line, they're going to make 180. Every time. Okay? All triangles add up to 180 for the inside angles of their triangles. Okay, so let's try a few. Interior angles of triangles have a sum of 180 is the rule. So We start looking, we first look and say, okay, yes, these are all interior, they're on the inside. And so I've got 25, and how much is that? 90, so 180 minus 25 minus 90. It's going to leave you with 65. Yay! So x, angle x will be 65. So that's how they're going to go. And 180 minus 65 minus 65 will be 30. No, sorry, 50. 50. All right, now, a little different on this one. X and Y are both on the inside, but the 150 is on the outside. So we can't do, when there's two missing, unless they match, you can't find it if there's two missing. So think back to last chapter and think, okay, what can I do with 150? 150 is sitting right here next to X on top of the straight line. 180 for that straight line minus 150 gives me 30. And then I can do my regular 180 for the triangle. Now notice, here's a little shortcut. When you do get a right triangle, this is 90 degrees. Well, the other two have to add up to be 90 as well. So that could save you a little bit of time. If I know I've got 30, then this other one's going to have to be 60. So, or you could do the whole 180 thing if you like. Okay, a little bit of change here. How many triangles do you see? 1, 2, there's actually 3. So there's a little one and a little one, and then the whole entire thing is a big triangle. So let's think about the whole entire thing first. We got 65 in this corner, we got 75 in this corner, and then the top corner's missing. Okay, don't put X, just say it's missing. So could we find the top? Yeah, 180 minus 65 minus 75. And that's going to leave you 40. Okay? So 40, now let's go over here and look at the X's. They match, right? So what does that mean about the 40? 2 equal pieces, so it's going to be split into 2 equal pieces. That gives you 20 and 20 for each one. Now take the left triangle. You got 65 and 20. Subtract it from 180, and Y is going to be 95. And then the same thing on the right side. You got 20 and 75. Subtract that, and you're going to get 180. You're going to end up with 85 for that other. So, not too bad. All right, what about this? We're going to see this a lot. What kind of triangle do you see here? I got 2 matching angles. Anytime 2 things match, that's isosceles. Okay? So isosceles means you got the matching parts here and here. Forget about X. We're not going to worry about X just yet. I need what for a triangle? How much does the inside of a triangle make? 180. I got 30. So let's take that 30 away, and that leaves us 150, but it's got to be shared between the 2 pieces. Are they equal? Well, then you can share it equally. In other words, you can divide it equally. So you end up with 75 and 75. Now how can we get X? Then that's the old stuff. Right next to 75, 180, subtract 75, and you get 105. Okay? All right, and then got one more practice here. All right, so how many triangles here? 3. You've got, you got the big one right here with 1 corner missing, right? Just one. 180 minus 60 minus 50 leaves you 70 right here. And then you've got the other triangle going this way. Okay, all triangles make 180. Now, is 70 part of that corner, part of that triangle? No, not really. 70 is the corner for the other one. So we're just going to look at this corner and 40 and 80. So 180 minus 40 minus 80 leaves us 60. Excuse me. Okay, so let me clean it up here. I got 60 here, I got 70 here. So what do I do about the top? 180 in this little triangle. It's going to give me 50, and then vertical, oh yeah, vertical freebie. X is 50. Now, this I used to have on tests. I don't think I'll have it on this next one. But be ready for the ACT for it. How many triangles? 1, 2, 3 little ones. But then there are 4. When you think about that one combined, those two combined, and the other two combined, 5. That makes a triangle. Or the whole entire thing, one big triangle, 6. So you can split it up different ways. You might not start it the exact same way somebody else does. So I'm going to start it here by combining these first two right here. Okay, in the corner I got 20, and in the corner, in this whole corner right here, I got 90. So that's an easy one. 20 and 90, I need 70 up in this corner, and that'll be right up here on the main drawing. Now you can do a couple different things. Don't forget your basics. We don't have any X's. We had a right angle, and it has been split, but we don't know what it's split, how it's split yet. But we do have supplementary right here. See, straight line. And we also have it right here, straight line. So 110 and 115. So then you can take it and look at the individual pieces. You got enough now. Look at all those little pieces. Individual triangles. In here I got 110 and 10, that makes 120, so I need 60 more to get 180 in that one triangle. Right here, 65 and 70, add them up, that's 135, I need 45 right here. Now I could do my 90 if I wanted to, or I can say this triangle right here, 115 and 20, that's 135, makes 45 right there. So that one just happened to cut it in half, but it didn't have to. Could have been two different orders. Alright, so you have algebra in this one, but the rules still apply. What is the thing that triangles make? The angles of a triangle, inside angles, add up to be 180. So you need to write an equation. Little piece, 64, not little piece. All the three angles, 64, 2x minus 5, and I can drop that parentheses off. That's just to keep it all together with the degree sign, and x plus 40. Totals up to equal 180. Kind of ran out of range. Alright, so 64 minus 5 plus 40. That's 104 minus 5 makes 99. 2x plus 1x makes 3x. Plus 99 equals 180. Move your 99. 3x ended up being 90 or 81. And 3 goes into that. 27 times. Okay, so x is 27. So you can plug it in. X is 27 plus 40, make that 67. 2x, 27 times 2, 40, 54 minus 5, 49. So try adding up 64, 67, and 49, see if it makes 180. I hope so, because I didn't check it with the calculator. Alright, little shortcut. The exterior angle theorem says that if you have an exterior angle, and that means it's the angle on the outside, of course, but it's the one that comes out, like you're going to extend the side out, one side comes out, and it's this angle right in here. Okay, that's the exterior. This would be just 180 under here. So it's just that part. It's not like it's this whole corner back here or anything. So just that exterior angle right there is always going to be a combined sum from angle A plus angle B. Whatever's over here, this is called the remotes. Now, remote, you think remote control on the TV, right? Why do we have a remote? Because the TV's way over here and I don't want to get up and change the channel. So, if I'm looking at this angle, what are the two furthest away angles? C? No, C's right here by. It's A and B. Those two will add up to equal this one. So if this was 40 and this was 100, then this would be 140 degrees. Just that easy. And that works every time with triangles. So if I have a little algebra with it, let's see if you can do it. What are we going to do? The two remotes add up to equal the exterior, and it's algebra, so it doesn't matter if it's algebra or not. The two remotes, 5x and 3x, add up to equal the exterior. Let's work. 5x plus 3x, 8x. Move your 2x plus 2x, 10x, so x is 10. And I'm not saying this is drawn on the right side, so don't freak out. So if x is 10, then this is going to be 30, 10 times 3. And if x is 10, this will be 50. So that means they're going to add up to be 80. 100 minus 2x. 10 times 2 makes 20. 100 minus 20 is 80. So they do add up to be that way. Like I said, one drawn the right way, but you'll get it.